Hello everyone and a very good morning to all of you, distinguished delegates, presenters and participants from SAARC member states and other regions around the globe. Ladies and gentlemen, a very warm welcome to all of you for joining us today for this video conference on Disseminate Action Plan for Electric Utilities of SAARC countries to introduce EV charging infrastructure. My name is Mehnaz Khurshid Garbezi and I work as a communication specialist at SAARC Energy Center. Aim of today's video conference is to disseminate the study and its findings, recommendations to delegates from SAARC member states, to seek feedback and comments on the study, and to raise awareness among stakeholders, especially the utilities and relevant decision makers. According to IEA's report, the number of EVs in the world has hit 7 million mark in 2019, and it is expected to grow to 125 million by 2030. A major driver for growth in EV sales is the easy access to charging infrastructure. In this context, SCC conducted a study in 2019 to facilitate the selected electric utilities of Bhutan, India, and Pakistan in formulating action plans for introducing EV charging infrastructure. The subsequent report has assessed the EV market in these three countries and devised an action plan for an electric utility in each of these three geographies to deploy EV charging infrastructure in their respective licensee areas. The report intends to allay some of the uncertainties of such utilities by suggesting scalable business models based on feasibility and workability. It is my pleasure to inform you that today we have Dr. Shoaib Ahmed, Deputy Director, SAARC Energy Center. We are very thankful to you, sir, for taking out time from your busy schedule to attend this video conference. So now I would like to request Dr. Shoaib Ahmed to deliver his welcome note. Thank you, sir.
Thank you, Mehnaz. Dear friends, colleagues, participants, and the presenters of the video conference. Assalamu alaikum and a very warm good morning. I, Dr. Shoaib Ahmed, Deputy Director, SAARC Energy Center, welcome you all to this virtual conference to disseminate a plan of action for electric utilities of SAARC countries to introduce EV charging infrastructure. It's a great honor for me to open the discussion on this important topic, which in near future will play an important role in deployment of cleaner transportation systems in the SAARC, as well as will improve the environment of the region. Dear participants, SAARC Energy Center is a regional institute on energy and a technical arm for the SAARC organization on all regional energy matters and associated fields. It is our endeavor to facilitate the adoption of modern energy systems and technologies by the South Asian nations for the betterment of their people. The center started its operations in year 2008. During last 12 years, the center has played its role in all regional level energy initiatives. Until now, the center has carried out around 170 interventions. The reports of all these interventions are available on the center's website free of cost to all living in and outside of the South Asia. Dear participants, in order to tackle air pollution and climate change issues of the region, electrification of the transport sector is very important. One of the major drivers of electric transport is the easy access to the charging infrastructure by the users of the electric vehicles. In this regard, electricity and supply companies have to play a major role in planning, providing, and ensuring reliable electric power for the charging infrastructure, which of course is expensive in terms of resources and difficult in terms of its implementation. So the electric utilities needs to find innovative business models to find additional sources of revenues, leverage their existing infrastructure for required electric resource, and start planning to make use of electric vehicle technology to improve the stability of their power grids. Dear participants, recognizing these challenges, SAARC Energy Center decided to chart a course towards a smooth and sustainable electrification of the transport sector. Accordingly, 2 research studies on electric vehicles in the SAARC region were carried out in year 2017 and 18. In year 2019, SAARC Energy Center coordinated with selected electric utilities of the SAARC member states and facilitated them in formulating action plans for introducing EV charging infrastructure. The current study report presents the center's efforts in this direction, with an ambition to embed the issue of the EV charging infrastructure high on the agenda of the member states, and also to become a driver for this positive change in the South Asia. Dear participants, this report is a result of substantial investment in time, efforts, and dedication of SEC staff, authors, reviewers, and many others. I would like to acknowledge their contributions and am sure that you will also enjoy the dissemination of this report, as well as will benefit from its findings and the results. Today's conference is a step in this direction. Dear participants, in this video conference, we have resource persons from Bhutan, India, and Pakistan who will disseminate the study findings and share their knowledge and experience through presentations and interactive discussions. I am delighted to acknowledge the great cooperation and support extended by all of them. In the end, I once again thank you all for joining the virtual conference. Please feel free in expressing your opinions and suggestions during the video conference and even after. With these words, I declare the session open and wish you all a very comfortable learning and knowledge sharing. Now, I would request my colleague, Mr. Umar Mukhtar, to take us through the rest of the agenda. Thank you.
Thank you very much, sir. I'm very thankful to all of you for joining us today in this video conference. My name is Muhammad Umar Mukhtar, and I'm working at SAARC Energy Center as Research Fellow, Energy, Transport, and Environment. I shall be moderating the technical session of today's video conference. I also thank Ms. Mehnaz for the opening session. Ms. Mehnaz has already provided you with the background of today's event. So without further ado, let's open the technical session. Our first expert, Mr. Pinal Mehta, has an overall experience of 19 years with 12 years of core energy industry experience. Mr. Pinal has been leading the energy, power, and petrochemical team at Chrysler Research in the areas of industry research, market entry strategy, market assessment, and commercial due diligence. He has also overlooked functions like strategic and business planning from legal, finance, and commercial perspective. Mr. Pinal is a company secretary and a law graduate and has worked on engagements as far as Nigeria, Malawi, and Nepal in addition to India. Mr. Mehta will be giving a presentation on global EV market, its size and opportunities. This presentation deals with the initial part of the study report and it sets the context for the subsequent action plans for the utilities of South Asia. Before handing over to Mr. Pinal, dear participants, I would like to inform you that you will have the opportunity to ask questions to the presenters by typing your questions in the attendees panel of the main window of the software. You may send in your questions at any time during the presentations. I will collect these questions and address them during the Q&A session at the end of each presentation. Furthermore, you can also ask live questions from the presenter during the question and answer session, for which we would request you to turn on your webcams. So over to you, Mr. Mehta.
Thank you very much, Mr. Umar Mukhtar. Very good morning to all of you. Thank you very much for joining. And Dr. Shoaib, thank you so much and also SAARC Energy Center to giving us the opportunity to work on this very critical aspect, which is the EV charging infrastructure. And of course, moving towards the cleaner energy globally, there is a definite push. And within SAARC Energy Center or within SAARC Energy region, also we need to focus on these aspects. So thank you so much again. And with this, I request my colleague Pramit to share the presentation. We can take you through the presentation. All right. So as highlighted by Dr. Shoaib and also by Mr. Umar Mukhtar, the presentation is on the action plan for electric utilities supply companies of SAARC Energy to introduce EV charging infra in the SAARC Energy region. While undertaking this study, we have undertaken study in three countries basically, India, Pakistan, and Bhutan. Very specifically, moving on, just to give you the background of CRISIL research. So CRISIL research has undertaken this study in India, very specifically on the EV charging infra, selecting a very specific utility. A brief introduction. So CRISIL Research is a part of S&P Global Group, which is a major rating agency based in US. And also we are part of India Research Team, and within India Research Team we undertake a lot of services basically in terms of ratings, in terms of grading of SMEs. Also we are providing services in infrastructure space, and also globally, and we have been providing the services in terms of global analytics and also the risk solutions. As a part of CRISIL research, we provide basically services under 4 buckets. One is the economic research, the industry research, where we cover more than 86 industries. We also provide services in the funds and fixed income research. And as a part of customized research, we undertake the bespoke or objective-based, very specifically meeting the client requirement. As a part of research offerings, we do provide services across business planning, strategic initiatives, whenever you are entering into new space, also undertaking the competition benchmarking, and also the fundraising and valuation services, which are part of the integral services that we provide within CRISIL research. Moving on to the flow of this presentation, very specifically. So what we are trying to cover in this presentation is the global EV market, the size and opportunities. I will take you through the section. Next will be the action plan for electric utility in case of Bhutan. So our colleague Mr. Sewang will take you through the EV charging infrastructure and the study undertaken and his findings in Bhutan. Next, my colleague Pramit Pal, he will be taking you through to action plan for electric utility in India. And finally, we will also take you through the study that we have undertaken in terms of Pakistan. So very specifically in this study, what we have done is we have looked at the global EV space, how the market has evolved over the years, and the major reasons for the same. We've also briefly looked at the evolution of battery technology and the battery swapping system, and how they had a bearing on the overall EV adoption. Then we have also deep dive into 3 SAARC member states, India, Pakistan, Bhutan, wherein we have selected a power distribution utility in each of the 3 countries and prepared an action plan for introducing EV charging infra. And also this report also act as, or can act as, a benchmark for other utilities so that they can, learn from the study, learn from the experiences of the author, and also, try to replicate the strategy or try to implement the EV charging infra for their respective utility. As far as the global EV scenario is concerned, the electric vehicle market has been growing steadily across the world, driven by majorly the developed economies. The evolution of green mobility has spawned across geographies, driven by the federal support, better products by manufacturers, and also strong private investment, and also, of course, the improved EV sales. The entire global stock of EVs has surpassed, as on date is, or in 2018, it has surpassed around 5 million. In Asia, China has been the biggest contributor to EV sales, while in Europe, countries like Germany and Norway, they are leading the pack. Although several drivers like economic advantage of EVs, rising customer demand has increased the EV sales, major barriers include high cost, and limited charging infrastructure. The barriers are more prevalent in the developing economies. In terms of battery technologies, if you look at how the battery technologies have evolved, so battery technologies and chemistries have evolved over the years, leading to increased battery density, modularization into smaller packages, which can be fitted in electric vehicles. There are majorly 5 lithium-ion battery technologies, namely NCA, NMC, LMO, LTO, and LFP. All have varying battery parameters. EV manufacturers take into consideration the advantage and the pitfalls of different technologies while making a decision on type of lithium-ion batteries that they use. So basically, what we've seen is manufacturer, there is no standardized battery, and of course we will connect go into further studies. However, very specifically, each and every manufacturer has their own proprietary battery as well as battery management systems, which is actually kind of acting as a barrier in introducing or standardizing the battery itself and commensurate battery charging infrastructure. Moving on to the battery swapping systems. So we've also looked at the battery swapping models that works on a tenant, where developed batteries or basically depleted batteries can be swapped with a new recharge battery with the same architecture. So here again comes the point on the standardization, whether the batteries are standardized, whether the manufacturers are using standard batteries which can be swapped. So that's again a major barrier in implementing this battery swapping system. Although there is economic viable business model that we have seen. So in India, if you see one of the state in Maharashtra and one of the city in Maharashtra in Nagpur, one of the cab aggregator, they've actually tried to implement the battery swapping model for the entire fleet of the cabs that they run on Indian roads. So keeping in view the economic viability, yes, it is viable, right? However, as I highlighted earlier, most manufacturers, especially in the passenger vehicle segment, they have not adopted this approach. Very specifically, keeping in view the proprietary battery, the battery management system, and in fact, they are not actually very keen to share their technology with their competitors, because that is the major USP that a battery can provide or a particular passenger vehicle can provide in terms of range and also in terms of the cost. There has been a slow uptake in battery swapping system even in the developed markets. So some two-wheelers and three-wheeler companies have, however, come ahead to adopt BSS to reduce range of anxiety and also the improve sales. So in terms of electric vehicles market overall, if you look at globally, it has been growing steadily across the world, but majorly driven by the developed economies. With maturing battery technologies and reduction in prices, the cost economics of EVs is expected to is expected to be strong in terms of electric vehicles and the other fuel, basically diesel vehicles and also the petrol vehicles. Also, battery swapping system is an evolving concept. However, majority of auto OEMs or basically manufacturers prefer to keep tight control over their design and battery packs, leading to the lack of standardization of EV lithium-ion battery packs. And also, we are seeing some of the other developments in terms of other technologies, which will have impact on the overall EV space in India. So that's to just give you the background of global EV or global scenario that we have considered and that we have studied, and some of the key conclusions that we could draw out from this study. I'll be very happy to answer any questions that you may have on this section, and very specifically post this we will cover Bhutan as a country when we have deep dive and undertaken detailed study on the EV charging infra.
Thank you very much. With this, I would like to invite our second speaker. Our second speaker is Mr. Shewang. He has more than 20 years of experience in the power and renewable space. Presently, he is the Assistant Professor and Dean of Academic Affairs at the College of Science and Technology, Royal University of Bhutan. He has rich experience in academic services, conducting research work and implementing new projects and initiatives which support learning and teaching. Mr. Shivang is an electrical and electronics engineer and holds a PhD from the University of Melbourne with specialization in renewable energy. Mr. Shivang's presentation will be on the action plan for Bhutan Power Corporation, and he will be dealing specifically with the electric utility of Bhutan. So over to you, Mr. Shivang.
Thank you, SAARC Energy Center for organizing this. Also, thank you, Cyril, for coordinating this presentation. Good morning to everyone. Good morning to all the participants and colleagues. As introduced, my name is Undp, and I work for the Royal University of Bhutan. At the outset of this presentation, I would like to state that this study was conducted referring to several government reports, regulations, and acts. Additionally, the team have also consulted the relevant government officials and the stakeholders involved with the EV sales, EV maintenance, and also the EV users. In this presentation, we will look at 8 different subtopics. We start with the country EV outlook, shortlisting of the distribution utility, and then charging standards, charging requirements, and also location planning for the charging stations, Capex requirement for utility, business model for setting up PCs, and also organizational capacity building. So with this, if we look at in keeping with the Bhutan's policy to remain carbon neutral and also reduce import of fossil fuel, the Royal Government of Bhutan introduced electric vehicles in the country in 2013. Since then, the government has offered fiscal incentives, devised policy regulations, and set up quick charging stations with free charging where the users need not pay. So as of today, the users do not pay anything for using the charging stations. So as of June 2019, there were 102 EVs. The Royal Government has launched a project to replace about 300 taxi fleet through the Undp JEF funding. Through this project, government is offering 20% subsidy. That is up to a maximum of 5,500 USD. So moreover, the financial institutes have also agreed to provide 50% loan equity. So it is expected that a number of EVs will increase over the next 2 years. Since the current fleet of EVs is minimal, which is just 102, and out of this 102, several EV taxis were not were off-road actually. So we have used 2 scenarios to study the readiness of utility for EV infrastructure. That is, we considered low and high uptake scenarios. In the low uptake, the number of EV was projected using 10% the annual growth rate, and also based on the growth rate up to 2019. For the high uptake scenario, we simply double the low uptake, that is at 20% growth rate. So it is projected that by 2030, there would be 948 EVs under low uptake and 2074 under high uptake scenario. So this shows the likely EV scenario, but it would be worthwhile also to note that this Undp JEF project, as every one of us are aware, due to the current pandemic, this has the government has not been able to launch this, although there were several announcements for this, but because of the pandemic, a lot of things are on stall, so probably this is not happening. I mean, maybe pushed to another year or next year. Next, please. In terms of government policies to promote use of EVs, the Royal Government, in an endeavor to push EV sales, has not imposed any taxes on the EVs so far. The government, through regulations, like the Royal Government has committed through NDC to remain carbon neutral, and also the Bhutan National Transport Policy 2017 also supports the EV transportation, then Bhutan Vision 2020, and also in the 12th five-year plan, that is from 2018 to 23, also talks about the change in transport sector from the conventional vehicle using fossil fuel to EV. So there is a lot of government policies, several government policies that would actually promote use of EV or adaptation of EV in next few years. Next, please. In terms of stakeholders that deal with the energy sector or that would directly be involved with the promotion of EVs would include at least there are 4 stakeholders. The first one is Bhutan Electricity Authority, which is the regulatory body that is responsible for the policies, regulations, and the determination of tariff. Second is the Department of Renewable Energy, which looks after the generation of all the renewable energy other than the mega hydropower. Then the third one is Duke Green Power Corporation, responsible for managing all the generating units in the country. And finally, the last one, that is the Bhutan Power Corporation, responsible for transmission and distribution of electricity in the country. So BPC, unlike in the other SAARC countries, Bhutan Power Corporation is the only utility company in the country. So all our studies, there was no question of choosing utility company. So it's a state way that BPC is the only utility company. So studies conducted in collaboration with BPC as well. Next, please. Government has actually shortlisted 4 EV model under UNDP JEF project, through which the 300 taxis will be replaced. Based on the specification of the current EVs and also the proposed EV taxi project, the team have recommended to either have a combo 2 QC or to have a Charimo faster DC chargers. In fact, when we talk to the EV taxi drivers and also to the EV users, one of the drawback of the current charging station is because there are limited charging stations in the country, so the EV users have to wait. There is a queue to charge their EV cars. So one of the recommendations from the EV users is to have combo chargers so that the users did not have to wait, or otherwise to increase number of charging stations. So that's the recommendation directly from the EV users as well as the EV owners in the country. Next, please. The number of QCs, the quick charging stations required during 2022 to 2030 was estimated based on the following factors. We assume that same EV model selected for implementation through the UNDP JEF project, because under this project there are 4 models selected by the government. So we assume that this will be continued beyond 2021. And as per based on the specification of the EV models that is selected by the government, the minimum range of fully charged EV is approximately 200 kilometers for the new EVs. Although as per the specification it says up to 300, but given the driving habits, the terrain that the country has, and the road condition that the country has, we assume that fully charged EV can fly for 200 kilometers once it's fully charged. And then we assume that charging stations are distributed along the highway and core public places. As of 2019, there are 4 quick charging stations. The government has a plan to install another 23 QCs by 2021, which means 1 charging station for every 15 EVs. So as the new EVs are expected to have a minimum of 200 kilometers per full charge, we assume that 1 EVs for every 1 charging station for every 20 EVs. So by 2030, it is projected, based on the number of EVs projected based on our model, we could have 47 EV charging stations under the low uptake scenario and 104 EV charging stations for high uptake scenario. These 23 QCs, the quick charging stations by 2021, it's unlikely to happen because of the current pandemic situation. So this may be shifted further to 2022 or so. Apart from the initial cost of EV and its operational range, the accessibility to EVs and cost of charging will have a direct impact on the adoption of EV. Therefore, we have considered the commercial hotspots, that is the office complexes, multiplexes, shopping centers, monasteries, market complexes, restaurants along the highways, expressway. So tentative EV location as per the current as per the government's plan is shown in the table. This is for the low uptake. And then next, please. Yeah, this is for this table shows the tentative EV charging location for the scenario under high uptake by 2030. Next, please. So as of now, 23 QCs per EBCs will install between 2019 and 2021 through the UNDP JEF project. For the convenience of financial analysis, we have assumed that the cost of 23 QCs will be transferred to the electric vehicle charging station operator in 2022. So cost of QC, each QC is around USD 26,000. Now this initial cost only for QC is based on the estimate from the UNDP JEF project. So all other costs, other than this basic cost of the QC, all other costs were derived based on the market cost as of 2019. So the total capex required for installation is 101 million for low uptake and 190 million for high uptake scenario. Next, please. The OPEX requirement for EVs. OPEX requirement for EVs was estimated considering several factors. We assume that each EVs will use 30 minutes per charge. That is assuming that each QC, quick chargers, are rated for 50 kilowatt. That is the normal QC's rating that is currently being used in the country. So based on that, so if each EV is using for half an hour, then that will consume or draw electricity of 25 kilowatt hour per charge. And each station needs a lease line. And then assuming 5 meter square length, but we assume that length, because government wants to promote EV usage, so lane lease will not be charged, and some installation cost, same installation cost in all the districts of Bhutan. So financial analysis was done at the discount rate of 10%, and we also assume that because we are talking about several quick charging stations, and also based on the feedback from the EV users, we found that failure of charging station is also one of the reasons that dissuade the people to shift from conventional vehicle to EV. So we assume that one technician would be required to maintain these quick charging stations, and then we also assume several other staff maintenance, network service provide, and then management software fee. So considering all this, the OPEX requirement was estimated at a 10% discount rate. Next, please. The financial viability for EV charging stations. Currently, the EV charging stations are installed and managed by the government. So to the utility company, that is the Bhutan Power Corporation, EVCS is like any other domestic consumer. So EVC's users did not pay anything. The monthly electricity bill for using the electricity from the BPC is actually paid by the government. So as of now, the EV users need not have to pay. Next, please. So to look at a different business model for operation of EVCS, we looked at 4 different options. Now, the viability of business in terms of operating EVCS was analyzed in terms of the net present value and also the payback period. So 4 different options are proposed. Option 1, that is business as usual. Government installs EVCS, manages and provides free charging. We say that this is not sustainable at all. This is the current practice. Then in the option 2 is the government installs EVCS and manages, but charge a nominal fee to the users for using the EV charging stations. A minimum of 20% utilization rate is required to make it sustainable. Then option 3, government installs EVCS and leases out to the utility or to any private company to manage, operate and maintain for a fixed term. So minimum 27% EVCS required, utilization rate is required. And then in the option 4, utility company or otherwise, what we are saying is that maybe through a PPP project model can invest in EVCS, operate, collect, and then also charge with this minimum of 33.33 or otherwise around 30% utilization rate is required to make it viable business model. Next, please. So under option 1, all other parameters for different options, option 1, option 2, and option 3, 4, we assume same cost. That is the price of new Nissan Leaf. The commonly used model as of now in Bhutan is Nissan Leaf. So this price of Nissan Leaf is based as of June 2019. So by this time, price would have actually changed. So new Nissan Leaf in June 2019, it cost USD 32,857. So fuel cost for a taxi, equivalent fuel cost, we were trying to look at how much fuel cost can be saved. So it is around for an average taxi driver, they spend around 360,000 for 6,000 liters of fuel per year. And this amount we said is saved if EV users need not pay for charging. Then the cost of the commonly used car in Bhutan is around, looking at an average cost of car, 10,000. So we need to look at how much savings in terms of initial investment. And then we assume that government will continue to provide subsidy beyond the year 2023 when the Undp JEF project ends. And payback period of differential cost, based on all these assumptions and the calculation analysis, the payback period of differential cost, the extra amount that the EV owner has to pay for EV is 3.2 years. And payback period of total EV cost is 6.4. So simply based on the payback period, we see very good business in terms of, at least for the EV owner. So if the government wants to promote EV, then providing free charging to the users would actually lead people to shift from conventional cars to the EV. Then in the option 2, all other parameters remain same. So in option 2, payback period of differential cost is 5.1, and then the payback period of total EV cost is 7.6. Now compared to option 1, the payback period is increased both for the differential cost as well as for the EV cost, because in option 2 we assume that EV users pay for using EV charging station. So that's why the payback period is slightly high. Next, please. Under the third option, we assume that the government takes the responsibility to install the EV charging station. and leases out to private company or the utility to manage, operate and maintain for a fixed term with the condition that at the end of the lease period, the lessee has to restore the EVs. So business model seems viable at around 27% of EV charging station utilization rate and electricity selling price of around near term 7 per unit. So if the government permits or if the regulatory body permits to increase the selling price or the selling price to the EV users at from 7 to 8 per unit, then the EV charging station utilization rate could be as low as 21%. Next, please. In option 4, the last option, the fourth and the last option is to build and operate by the utility company or through a public-private partnership project. In this option, the utility company or through PPP will invest. So government need not invest anything in this. So PPP will invest in EVCS, operate, collect charging fee and from the users and also upkeep the EVCS. So in this model, in order to avoid exorbitant electricity selling price, the government has to prefix the price at an admissible rate which benefits both the operator and the EV users. So recommended minimum electricity selling price in this option is around 9 per unit. Next, please. So comparing these 4 options, if you look at option 1, we say that option 1 could promote and encourage people to switch from conventional vehicle to EV, as there is potential for substantial saving in fuel cost. But it is not recommended, as this option would not be sustainable in long run. In fact, from the survey, informal survey that we talked to the EV users and also the EV taxi users, in case if the users, if the EV owners or the users have to pay for using the charging stations that is installed in the country, then there are chances that the owners may switch back to the conventional vehicles from EV. So currently, I'm sure this is also true in other countries. In Bhutan, the most key or the key driving factor for promotion of EV or for switching from conventional vehicle to the EV seems like free charging that is available in the town. So the users need not pay. In fact, they get free fuel to drive their cars around. So that is the key factor which will promote the switching of conventional cars to EV. Under option 2, EV users have to pay a minimal price, but the government will not be able to recover the investment. Therefore, this is also not recommended. Under option 3, government does not have any risk and will also be able to recover the investment at the end of lease period. Therefore, this option is recommended as a good business model. Option 4 is to invest and operate by utility company through PPP. Seems to show reasonably good business perspective, but there is associated risk of failure in EVCS utilization if the EVCS utilization rate is below 33%, and if the bank charges very high lending rate. Therefore, this option may be pursued with caution. Next, please. So as stated earlier, the EV project is currently managed by a separate project management unit. Just now, this EVCS doesn't fall under the utility company. This is managed by a different project management unit under the Ministry of Information and Communication. As EV deployment grows in the next few years, the number of home chargers will also increase. The unprecedented increase of home charges could lead to uncertainty regarding the residential power demand. If EVCS infrastructure is owned and operated by utility company, then it would be able to manage peak demand due to quick charging stations and also home chargers, and at the same time modulate the power flows between the grid and the consumers. Next, please. So BPC, the only utility company in the country, Bhutan Power Corporation, is a 30 billion company with more than 2,500 employees and a strong balance sheet. The team feels that BPC is well suited to invest in EVCS infrastructure, as it would have access to low-cost capital, skilled human resource, experience of large-scale projects, and in-house training division. So, under the BPC, if the utility company, the Bhutan Power Corporation, intends to take up, maybe separate division is required to manage EVCS, electric vehicle charging stations, which can be placed under the distribution and customer service division, which is the Department of Distribution Services now. Next, please. Okay. And as of today, there has not been any reports of impact to the grid that can be directly attributed to EVCS. However, utility is being proactive in planning for increased EV deployment and assessing grid capacity. And at the same time, the utility company representative is also participating in EV project as a technical committee member. So from the modeling and simulation of, we have done a very comprehensive and detailed modeling of the simulation of the transmission and distribution network of the capital city of Bhutan. From the modulation and simulation till 2030, the numbers indicate that utility grid can actually accommodate EVCS project in this EVCS project as projected based on our assumptions. The state of transmission and the distribution grid infrastructure is quite strong, and it is evident that infrastructure upgrades may not be required until 2030. If based on the whatever assumptions that we have stated in the earlier. Moreover, the utility is also in the process of establishing distribution management system in Thimphu, and also drafting smart grid master plan for whole of Bhutan. So with the implementation of DMS and smart grid in the next few years, the utility seems to be prepared for EVCS infrastructure in the network. For utility company, next please. For the utility company to invest and operate EVCS business, total cost over 9 years, that's from 2021 until 2030, would be around new 154 million for low uptake and 316 million for high uptake. So in conclusion, next please. In conclusion, the 4 business models that we have proposed is based on several assumptions. That is, we assume that land will be available free, but this will apply only if it is a government land. So if it is not, if the company has to lease land from the private owners, then the land price is very high. So this would actually increase the cost of investment and the operation, and which will in turn increase the cost of selling price of electricity to the EV users. And the other is upfront cost of EVCS. The cost of QC is quite significant and could present a significant barrier to charging infrastructure deployment for the utility. Taking loan will also increase the further electricity selling price. So as a consequence, EV users may be dissuaded from using quick charging stations. Based on the 4 business models, the first option seems viable, which is providing free, also based on the feedback from the EV users. So one of the motivating factors to shift from conventional cars to EV is free charging provided by the government. When we were serving, there also we have also come across some government officials. If the government continues to provide free charging stations, then the government offices would also like to shift from or switch from conventional cars to EV. So the key factor that will promote EV in long run seems free charging, but in terms of business, this will not be sustainable. So our recommendation is to go with option 3. With this, thank you. If there are any questions, then it would be my pleasure to take. Thank you.
Thank you very much, Mr. Shivang, for a very, very comprehensive presentation on the action plan for Bhutan Power Corporation. Just to summarize, you comprehensively dealt with the overall context, the different technologies under consideration, the charging locations, and then you went on to address the different options under consideration for in terms of business modes that BPC could adapt. We do have a number of questions which are addressed to you as well as to Mr. Penal. So I would like both of you to be available. So if you feel one question could be asked better by Mr. Penal, he could take over. So I move towards the questions. The first question is by Shri Singhal from India. What will be the impact of battery swapping on power demand and tariffs? So I guess this is in context of the first presentation by Mr. Penal.
Well, very tightly, highlighted. As far as the power demand from a battery swapping is concerned, it all depends upon the kind of ecosystem that we develop in India. And I mean, in that case, for any country, be it India or be it Bhutan or Pakistan. However, it all depends upon the kind of, the standardization of batteries that will be adopted by the manufacturers, the kind of policy or regulatory aspects which will actually support this kind of standardization. And definitely going forward, the kind of penetration that electric vehicles itself will have. So all these aspects will definitely have a important bearing on swapping of batteries model basically. And definitely, with the advent of swapping batteries, there's going to be the impact. However, it all again depends upon the regulatory system in every country. So for example, if you ask me in India, we have, different states following different tariff. So for example, in Maharashtra and India, or for example, in Mumbai, we are charging the tariff which is applicable to commercial and industrial segment. Okay, and for example, in some other states, it could be ₹6, which is a kind of subsidized tariff which is provided. So it depends upon the model. In addition to the electricity tariff, definitely there's going to be another charge which will be, chargeable by the battery service provider. So he will also have certain margin in terms of, the final the charging cost that you will have. So it all depends upon the entire penetration, the policy and regulatory push, and the different regulatory aspects. But definitely, it is going to have the impact again, depending upon the power demand, which will be driven by the penetration of battery storage or battery swapping model.
Thank you so much. So the next question is by Sarbagya Tuladhar. It is addressed to Mr. Shivang. The question is that what is the excise duty on the import of EVs into Bhutan? Also, does the government still promote free EV charging at its stations?
Thank you. As of today, EV charging is free. Whatever charging stations are there in the capital is still provided free. The government is still working on with the utility company. It's not defined yet because the whole UNDP JEF project is looks like it's on hold as of now because of the pandemic. So it seems they've not been able to launch. In terms of excess duty, as of now, EV do not pay any tax So in Bhutan, the tax is it goes up to 150%. So they do not pay any tax. There's no excess duty. Everything is exempted for EVs. Yeah.
All right, perfect. Another question which is in continuation of this question is that what is the current status of UNDP JEF project of 300 taxi fleet electrification?
Yeah, as I mentioned earlier, it's very difficult to know just now. There were several announcements about the launching of this UNDP JEF project, and there were also news that the current taxi drivers who wanted to switch over to EVs, they have registered and they were ready to take on the vendors that were identified by the government to import these 4 models were also ready. But this was supposed to be launched in the spring of 2020. So as you know, now everything is on hold. So currently it looks like it's on hold. Yeah. Even the government officials, I don't think they have a ready number to say this. So it's on hold. But probably by late 2021, I'm sure it will be relaunched. That's what I feel. But we are optimistic because based on the reports shared by the government, there were interested taxi drivers who wanted to switch over to EVs. But the bottom line is they are all basing on that government will continue to provide free charging. So that's the key factor. Yeah.
All right. Another question is how many EV charging stations are there in Bhutan at present? This question is by Shri Singhal from India.
As of 2019, there were supposed to be 4, but only 3 were working. Yeah, unfortunately. Yeah.
So if I may ask, currently for the taxi fleet in Bhutan, so are those 4 charging stations catering to that taxi fleet, or are they separate from the fleet?
The charging stations are common to all EV owners. But with the UNDP JEF project, they will bring in 23 quick charging stations. They've even identified, as we have in the report, they've identified the location where to install. This includes both the commonly visited places, including the highways near the restaurants along the highway. So this 23 is distributed in three districts. We call it as Songkhok. So 3 districts. So it's distributed. Some quick charging stations were already imported but not yet installed. So that's the status as of now. But otherwise, there were 3 working. Yeah.
All right, thank you. There's a question from Mr. Athar Rahman from Pakistan. He's asking, does Bhutan give licenses to EV charging stations that are being set up for domestic use, or do the domestic consumers require any sort of licenses or any permissions?
For the quick charging stations, as I presented, quick charging stations are installed by the ministry and it's managed by a project management unit. So because it's a government owned and operated managed by the government, so there's no question of license. For the EV owners who use home chargers, also there is no separate regulation as of now. As long as your distribution system or the individual flats or the buildings distribution system is able to carry the load, withstand the load that is coming in with the home chargers, so there is no separate requirement for permission from the utility company as of now. But there are also because I also talked to a few architects who are very popular in the country designing the private residential buildings. They said that now they are discussing to keep provision for home chargers as well, even in terms of shades where to have home chargers, so that the tenants can plug in anytime when they park their car over the night. Just now, because there wasn't any provision for such designs, just now what they are doing is the tenants from their own flat with the I'm sure this is also maybe similar to other developing countries. They bring in with the extension codes and then plug in. So that's how they are doing. But in future, we can see some changes even in the building design.
All right. There's a question by Sharad Bahadur Karmacharya. The question is, in option 3, can private company that is operating the charging station, can it set the price of charging, or is it regulated by the government? What is your recommendation?
Our recommendation is to be regulated. If we leave it to we cannot leave it to the market force, and we cannot leave it to the private sector as well, or to the owner as well. Otherwise, there's a risk of business failure. So, because if we charge high, then EV users probably will shift to home charging only, and there may not be users. And then this may the taxi drivers, because government wants to target the taxi drivers, taxi fleet. So taxi drivers, I don't think they can afford for very high electricity charging rate. So it has to be negotiated between the regulatory body as well as the private sector who wants to operate these EV charging stations. That's our recommendation in the report.
All right, thank you. There's a question by Mandira Adhikari. Free charging for EV in Bhutan. So this promotional model is intended for certain locations, or is it for a certain time, or is it a long-term plan?
As of now, there is no definite answer for this. Government is still discussing on this, whether to continue with the free charging to the EV users, or there will be, but they will be charged to a certain extent. But our recommendation is not to continue with this free charging, at least to charge, either to recover in the option as we have in the option 2. In the option 2 is the government who will invest in the charging station, but charge the users a nominal fee to recover the operating cost, at least the operating cost, if not the investment, the full investment, but at least the operating cost. That may be more viable if the government wants. But of course, option 1 will definitely promote, but in long run, that will be very expensive for the government to run.
All right. There's a question by Mr. Asjadullah Qureshi from Pakistan. What infrastructure change is required for installation of EV charging stations? Does the distribution company need to add transformers or other equipment to the infrastructure to facilitate EV charging stations? So basically, this question is in context of Bhutan. What is your understanding, and what is your recommendation?
EV charging stations, when we talk about EV charging stations, we are recommending quick charging stations. So these quick charging stations come with a transformer of 50 kilowatt rating. So definitely we have to buy 50 kilowatt. So one of the determining factor to locate the quick charging stations is not only the number of cars available, but also the cost of installing this. Cost will depend on land and also on this transformer. If there is no distribution transformer nearby, then we'll have to bear the cost of distribution transformer itself. So when we say this quick charging stations will be placed along will come into place along the highway, we looked at where there are low tension lines available or not, because if there is no low tension lines available, then the owner or the government will have to invest to bring in low tension line. So that will increase the cost substantially. So therefore, we have taken care of all of this. So quick charging station will need a 50 kilowatt transformer as well.
All right. This question by Sarbagya Toladhar. What other incentives are provided to the EV vehicle users, such as any tolls which are made free, or any other parking incentives, or any other incentives which you have in your consideration?
In terms of incentives, because otherwise also in the model 1 is charging is free. In the model 3 we have not recommended any incentives, because as of now only incentives that we can think of is in terms of tax waivers. So tax is already, there's no tax on the EVs, whatever tax it may be, there's no tax. And in terms of tollways, we don't have any tollways anyway, so that doesn't apply to Bhutan. And in terms of parking, yes, there were issues with regard to parking, but from the people that we talked to, they were not concerned about parking space as such, but they were more concerned with the parking space nearby the charging stations that we have reflected. Because there is a charging station, and then next to charging station, there are, besides that we visited, there are 2 parking slots for the EV, but some other people have parked, not EV. So that was the only issue. Otherwise, in the report, we have not recommended any incentives because tax is not applicable. There's no tollway, so we couldn't think of any other incentive other than this increasing the parking space. That's the only thing we have in the report.
All right. So now we'll move towards the last few questions. I request the participants, if they have other questions, we could address it towards the end of the session. So we just have 2 more questions. One question is, EV payback time under preferred option number 3 is 9 to 10 years. Do you think this preferred option for utilities will be beneficial for users in terms of promotion of this technology, or is the cost still too high?
Under option 3 is the option 3 is trying to what we're saying is recover the cost from the users, both the investment and the operational cost. So because we are trying to recover both the capex as well as opex for the EVCS, so the cost is high. So the users, EV users, will have to be charged certain minimal amount for per unit of electricity used to charge their cars. So this increases the savings. This reduces the savings for both in terms of differential cost as well as new EV cost or the full EV cost. So payback period is high from model 1 to option 1 to option 4. So payback period will go on increasing. Option 1 is okay 3.6 years. I'm sure if you have option 1, everyone would like to go for option 1. But option 2, option 3 payback period is significantly higher. And if this applies to the taxi drivers or otherwise to the private EV owners, this is significantly high, and we are afraid that there may not be many who would like to switch over to EVs from the conventional cars. It's high.
Right. So the next question is also kind of linked to this question. The exact question is that Bhutan Electricity Authority determines the domestic electricity tariff for LV, MV, and HV. Isn't 9 rupees per unit contradictory to this tariff determined by Bhutan Electricity Authority, as it seems much higher to the existing domestic electricity tariff? So would you like to answer to this question? Kind of similar.
Yes. When we say 9, that's in the option 4. In option 4, Bhutan Electricity Authority determines tariff only for the consumers. Now, for the EV charging station operator, this is resale of electricity. They buy from BPC, from the utility, or otherwise, if it is the utility company that will invest and operate, that means you still have to pay electricity when you buy, and it is sort of like value addition. You give it to EV users, so it has to include the cost of operating, cost of investment. So therefore, our recommendation is 9. Maybe if we go for option 4, business model option 4, then 9 is the minimum that need to be charged. So therefore, it's also not recommended. Option 4 is fully private. You invest, you operate, and then you maintain, also charge to the EV users. So we are not recommending option 9. So I'm sure no EV users would be ready to pay 9 per unit of electricity. So therefore, it's not recommended.
All right. And one final question. This question is by Mandira Adhikari. In monetary terms, what is the difference between the operational cost of petroleum vehicles and electric vehicles? Has any comparison been done for Bhutan?
Not exactly, because in terms of EV users, what we have done is we have calculated the avoided cost of fossil fuel. For as I have presented, also it's in the report. For one taxi driver, on an average, for one taxi on an average, in a year spends 360,000 as a fossil fuel cost.
Right.
That we have to understand that is taking into account also the fossil fuel is highly subsidized as well. So it spends 306,000. For us, we assume that if someone switches over to EV, then that 360,000 newton is avoided cost in terms of fuel cost, and that we take it as a savings and use it to calculate payback period and the present value. That is under option 1 only, but option 2, that is not fully savings. 360,000 will not be saving because you still have to pay. So based on this, we have calculated different savings for option 1, option 2, option 3. So savings from option 1, 360,000. Option 2 is lesser. Option 3 is lesser. Option 4 is far lesser. That's why the payback period has increased, because you have to pay for the electricity. In option 1, you don't pay anything for the electricity usage. So all 360,000, whatever amount you would spend for fossil fuel is saved. That's how we have calculated.
All right. To all the participants, the presentation is uploaded under the handout tab of this webinar interface. So you could go to that tab and download the presentation. And to the to Mandira Adhikari, the particular savings that Mr. Shivang is referring to, these are mentioned in the slide number 27 to 31 of the presentation. So you can access the presentation and look at the numbers in detail as well. So with this, we conclude our question and answer session. Thank you very much, Mr. Shivang Glenduk, for a very comprehensive briefing on the action plan for Bhutan Power Corporation, and for taking a lot of questions from all the participants. I'm sure there are still some questions coming in, so we would refer these questions at the end of the presentation to you. So I would like to request you to stay available till the end of this session as well. Thank you very much once again.
It would be my pleasure, please.
So, dear participants, with this, we move on to the next technical presentation. So our next presenter is Mr. Pramit Paul, with approximately 2.5 years of experience in energy and power industry and 4.5 years of overall experience. Pramit Paul is currently working as Senior Research Analyst with Crisil Research India. He has worked across several business areas, including e-mobility, power, and renewables. Pramit has executed assignments on market assessment, project feasibility studies, commercial due diligence, business, and strategic planning. He is an electronics engineer and holds a postgraduate degree in business management with specialization in finance. Mr. Paul will be sharing the action plan developed for BSES Yamuna Private Limited, India. So over to you, Pramit. So the screen sharing will be done by Mr. Peenal. So please allow Mr. Peenal to have the screen sharing option. But now.
Yeah. Am I audible?
Yes, you are audible.
All right. Thank you everyone. So good morning or good afternoon to everyone who is viewing this webinar from wherever you are in the world. So so I would be walking the participants through the research findings which we have done for the country of India. Uh, so going through the methodology which has been followed by the study, I would walk you through the overall methodology that has been followed for the country of India. Although the methodology is broadly similar to that has followed in the case of Bhutan, which was earlier explained by my colleague Mr. Shewang, the additional step that was undertaken in the case of India was shortlisting the power utility distribution utility for detailed analysis, as stated in step number 2, and then subsequent development of a business plan under the subsequent steps 3 to 8. In the forthcoming slides, I will highlight in detail as to how each step has been undertaken and what was the outcome that was obtained. Moving on to the next slide. Yeah. As part of the first step, we have undertaken an outlook for EV sales in the country up to fiscal 2030. So as known that this study was undertaken in 2019, and considering the demand drivers and the constraints, the determinants of success and failure, we have determined the outlook of EV sales in the country. So presently, as highlighted in the table above, the penetration of EV across all vehicle categories is low, around less than 1% even. But going forward, we expect to see an uptick, especially in the auto and two-wheeler segment, due to favorable total cost of ownership economics playing out for EVs vis-a-vis the ICE vehicles. And by fiscal 2030, we believe that the bus segment, majorly operating under state transport units, as well as the cab aggregators, will see a major shift towards EVs, as the cost of acquisition for EVs reduce, owing to reduction in battery prices itself. All in all, we believe that the overall population for EVs in the country is expected to reach somewhere around 80 million by fiscal 2030, with e-rickshaws and e-two-wheelers contributing to a majority, around 85% of the overall population, while buses, commercial vehicles, commercial category of passenger vehicles would also contribute around 5 to 10% of the overall population. Moving on to the next slide, wherein we talk about the regulatory and federal policies driving EV adoption in the country. On the regulatory side, several policies have been brought out by the government in order to provide a thrust to EV sales and EV charging station adoption. For example, the key policies which has been rolled out recently by the Indian government includes the National Electric Mobility Mission Plan, or NEMPP as popularly known, or the FAME, which is faster adoption and manufacturing of electric vehicles in India. And the second iteration of FAME has also been launched recently. Also, the new announcements which has been made by Ministry of Power by setting out the guidelines for EV charging stations, and also delicensing of EV charging station operators. They seem to be steps in the right direction, which are expected to push e-mobility goals for the government. As part of the next step, a private electric utility was shortlisted for the study, wherein we elaborate as to how we have gone about devising a benchmarking model, wherein we assessed the key operational, financial, and other parameters across all major power distribution utilities in the country. And then what we have done is we have rated each distribution utility on the measurable parameters. Some of the measurable parameters can be found in the table above, right top corner. So for each and every of these distribution utilities, we have captured the measurable parameters, and we have devised a final and composite score by risk weighting each and every parameter. And based on the final scoring, we have shortlisted distribution utilities, as shown in the table below. And post that, we have finalized the private utility based on interest evinced and the intention to mutually work with CRISIL Research on the project. Yeah, so once we have shortlisted the utility, we have deep dived into formulating an action plan for development of EV charging infrastructure for the utility in itself. And as part of the process, we have suggested on the type of chargers and charging requirements which are to be used by the private utility at the EV charging stations set up in their licensee area. And as far as India is concerned, the Bureau of Indian Standards, or BIS, they've already set up a committee which has been formulating standards for EV charging in the country. And as part of that, the Ministry of Power has also come out with the type of connectors and charging voltages which are required under each and every charging mode. And based on CRISIL research analysis, we believe that initially slow charger installations will be more because of tepid uptake of EVs in the country. But as EV penetration increases going forward, we believe that installation of fast chargers will make more and more economic sense in the country. Moving on to the next slide, wherein we have estimated the outlook for charging requirement in the utility area in itself. So what we have done as part of this step is we have undertaken a detailed analysis for estimating an outlook on EV charging requirement in the private utilities licensee area up to fiscal 30. And we believe that this will act as a precursor towards planning for the number of EV charging stations which would be required to be set up by the utility in its licensee area over the next 10 years or so. And as the private utility which we have been deep diving into, it caters to a part of the National Capital Region, or NCR, of which Delhi and its adjoining areas are a part of it. So we have done a two-pronged analysis by assessing the native EV population in the region in itself, which means that the EV users who are residing within the licensee area, while also we have looked at the floating EV population, meaning which the EV users who do not reside in the licensee area, but they commute to the area frequently for several purposes. And so cumulatively, we have determined the broad EV population that is expected to cater to that area. And then we have deep dived into overall charging requirement that would be required to be set up in that private utilities licensee area to cater to that EV population. So based on the analysis undertaken, we have deduced that the additional load that would be emanating from EV charging would amount to somewhere around 258 million kWh, or kilowatt hour, and around 720 million kilowatt hour in fiscal 2024 and 2030 respectively, as shown in the table. However, we believe that through timely remediation strategies, the challenges owing to increased load profile can be mitigated. They include like optimal placement of charging stations such that the load on any specific DT or distribution transformer is not very high, leading to tripping, or sound distribution network planning, wherein the degree of overloading needs to be checked and proper load flow analysis can be undertaken. All these steps can actually help to improve network augmentation and enable the increased rise of EV charging and power requirement in that specific area. And with respect to EV charging requirements in itself, we believe that more advanced techniques like managed charging or vehicle to grid charging can be introduced at a later stage, maybe beyond 2027 or so, when the EV population might increase to a large extent and distribution transformers may not be able to cater to the entire load in itself. Moving to the next slide, wherein we have deep dived into the location planning for EV charging stations. So here we showcase to you the broad methodology how CRISIL Research has undertaken location planning of EV charging stations in the private utilities licensee area. For example, we have looked at the major demand side planning, which includes assessment of pockets for penetration of EVs, like high-end residential pockets or commercial hotspots, shopping malls, eatery spots, so on and so forth. Additionally, we have also looked at the major expressways or highways which are passing through the private utilities license area. And then we have assessed the charging stations which would be required based on the outlook for EVs which was earlier given for that particular stretch. And as part of the last step, we have assessed the charging behavior of EV users. So we believe if you even look at the charging style for EV users abroad, close to around 95 percentage points of charging happens through home chargers even today. So we try to assess that whether Indian users will use more or less of charging through public charging stations. And all of these assessments have gone into undertaking a location planning for EV charging stations in the private utilities license area. Moving on to next slide. So here in this slide, we have highlighted in detail as to how we have evaluated each and every division under the utilities area that is being catered by the private utility, and we have assessed across major 4 categories or parameters. It is economic profile, connectivity, availability of public spaces, and proximity to commercial hotspots, because we believe that these 4 parameters would be the key driving points for EV penetration or requirement of EV charging stations in itself. So we have evaluated each division and ranked them, and finally we have developed a priority list for introducing EV charging stations in each and every of these divisions under the private utility. And we have deduced that out of the 14 divisions which is catered by the private utility, we believe that 6 out of 14 divisions are suitable for public charging station installations. And within that also, we have color coded each division to assign a priority for setting up of charging stations in itself. Moving to the next slide, wherein we are deep diving into the Capex requirement for public charging stations. So if you remember in guidelines that were issued by Ministry of Power of India in December 2018, that dictated public charging stations should have 1 or more electric kiosks or boards with installation of all charging models. But based on CRISIL research analysis, the Capex requirement for public charging stations with 5 chargers comes to be very high, to be around 20 odd lakhs to 24 lakhs. But now the rule has been disposed of, and charging station developers can utilize lesser number of chargers based on potential requirement. We believe that fast chargers are presently not viable in the country, economically at least, because fast charger with around 50 kilowatt hour of output can cost as high as around 15 to 20 lakhs. And with low uptake of EVs, we believe that charger utilization is expected to remain low and will not be able to justify or substantiate the high costs. However, government support either from the federal level or state level can reduce upfront costs, especially in the initial market development stage. We have also seen some of the EV policies which has been rolled out recently by states like Delhi. They have also tried to subsidize charger rates to a large extent to uptick the initial market, and they believe that this can bring more investors into the private charging station space. Moving on to the next slide, wherein we have quantified the financial viability of EV charging stations, taking into consideration the capex and opex costs that would be entailed by the developer itself. So based on our financial viability assumptions, we believe that station utilization will increase from around 15% in the first year to 50% in the 5th year. So considering these assumptions, and also considering that margin on electricity tariff that would be charged would be somewhere around 2.5 rupees per kilowatt hour, project IRR comes to a low of around minus 25 percentage points. However, we believe that in case EV station equipment is subsidized to a high of 75%, the station will be able to break even in 5 years. This also deduces the fact that station owners either have two choices. You either set up only slow chargers to reduce the high capex costs that would be incidental, or you increase the payback period expectations to upwards of 10 years. So based on our analysis, we believe that setting up of slow chargers would be the way to go, at least for the next 5 to 6 years in the country. Moving on to the next slide. So as highlighted in the table, the private utility can enter into EV charging business by adopting any of the four potential business models. The first being the make ready, which is the utility invests in make ready public charging station installations, wherein someone else might have done the investment through their own costs. The utility takes an exposure to that public charging station. The second would be giving rebates to EVSE vendors on the host sites. The tariff can be modeled in such a way wherein both the station owner as well as the utility will be able to reap benefits. The third option might be to develop charging stations through public-private partnerships, wherein while the fourth option speaks of owner-operator mode, where the utility owns the station in entirety and also operates the same. Risk in case of first model would be minimal, and losses to the utility would only be to the tune of the level of investments that has been made. However, the risk in the case of second and third model is moderate due to the high exposure that you are taking, and also owing to uncertainties of station utilization. Risk in case of fourth model would definitely be the highest, as the utility pools in capex as well as opex requirements for the EV charging station in itself. Moving to the next slide. So yeah, this slide gives a sense of the potential business models under which an EV charging station can be set up in a country like India, especially when EV users are low and charger costs continue to remain high. So we believe that EV stations can be set up near commercial hotspots like multiplexes, malls, shopping centers, cafes, where revenue from these commercial centers can be clubbed with potential revenue from an EV charging station. This will help in making a more conducive economic and business case for charging stations. We also believe that it will be difficult for standalone EV charging stations to be economically viable at this point of time, at least, due to low station utilization. Moving to the next slide, we have highlighted the key risks in EV charging station business. Here, we believe that the major risks would be low station utilization or lack of private investments in the public charging station space. Also, high cost of funds due to the lack of financing options for setting up of public charging stations. These would typically be major risks entailing this segment for now. As part of the next slide, we have charted a roadmap for the private utility for public charging installations over the next 10 years or so. So if you see the graph, figures fiscals 2020 to 24 is a period where we believe that EV penetration will remain low, even in a place like National Capital Region. This will not necessitate the requirement of large-scale EV charging stations, at least public charging stations. Therefore, we believe that the recommended model for setting up these PCS or public charging stations would be through PPP mode or public-private partnership mode. The keys to success would be to identify and set up these charging stations at suitable locations, so that station utilization is expected to be moderate, and you don't fall into the risk of very low station utilization and stranded assets. However, in the next 6 fiscals, which is from fiscal 2025 to fiscal 2030, as penetration of EVs increase or are expected to increase, the utility can look at setting up charging stations at strategic locations for by using its own funds, while also setting up additional stations under PPP mode. The keys to success during this time period would also be to develop PCS as a self-sustaining business model without the support from other business areas. As part of the next slide, we speak of the organizational capacity planning of the private utility for rolling out these EV and EV charging programs by the utility in itself. So we believe that before entering this EV charging station business, it is important that the organizational structure and processes of the utility are aligned towards the bigger e-mobility goal, because traditionally public or private utilities are not into the business of EV charging businesses. So it would require utilities to think out of the box, to think beyond the conventional business models, to actually go and invest into EV charging stations or e-mobility in itself. So we believe that the organizational structure can be rejigged in order to align with the larger e-mobility goals of the utility. We believe that new talent with experience in the EV space can be hired to drive the business. The three business areas which we have titled as operations, licensing, and marketing, they can come under one EV cell, which can be developed for driving this e-mobility goal of the distribution utility. The EV cell can be under direct control of the company management to increase the decision-making process and transparency. So moving to the next slide. So this broadly brings us to the end of this section. To summarize, as I highlighted that India is expected to be a very promising market for EVs in the next 10 years or so, although the initial traction may be on the lower side. But going forward, because of regulatory support and policy interventions and also private public-private partnerships, we believe that EVs is expected to poised for a large boom, especially fiscal 2025 and beyond. Fast charges, as I said, it would not be viable in today's time because of very high costs and low penetration of EVs. Therefore, we believe that slow EV charging stations would be the thing to go, at least for now. But we believe that economics would tip the scale as EV sales grow, EV population grows, and the requirement of charging in itself grows. Therefore, fast charging stations can be and would be economically viable in the next 5 to 6 years, especially in corridors which has a lot of traction of EVs across major expressways or across key commercial and residential hotspots. The private electric utility, as we spoke about, has been advised to set up the public charging stations majorly through the PPP route as of now. But beyond fiscal 25, as battery technologies mature and EV penetration in itself grows in the region, we believe that owner-operator route can be explored by the utility, while also keeping the public-private partnership model as the mainstay for the distribution utility. So yes, this is what I intended to speak of in this webinar. I would be happy to take questions from anybody in the quorum. Thank you.
Thank you very much, Pramit, for your presentation for BSCS Yamuna Private Limited. Let's move on to the question answer session. So the first question is from Sharad Bahadur Karmacharya. He's asking what technical studies were carried out before estimating the installation of charging stations and their locations.
Right. So as I highlighted, that technical studies were we had very deep discussions with the distribution utility in itself. We spoke to their the key management personnel, the key decision makers of the distribution utility, try to understand what is the load flow analysis that they had done inherently, try to understand what is the distribution transformer loading levels in the different regions. So that gave us a perspective of how how the distribution planning has been done across the region, and whether that would be able to cater to the EV load that is expected to pan out in the next couple of years. That is number one. The second is that we have in itself tried to understand what would be the EV penetration in the overall region. So that was another key parameter to understand, wherein we try to understand what would be the key pockets where EV sales would boom in the initial years, and which are the major commercial complexes, which are the major residential hotspots, which are the major roads and infrastructure that are which resides as part of that distribution utilities area. So using these two analyses, we deep dived into a location specific study, wherein we finally deep dived into the locations wherein EV charges and EV stations would make economic sense.
All right. So the next question is that what should be the guidelines for a layman for having charging points at home during home construction?
So for a layman, I don't think that there is any specific charging requirements per se. So with every EV that you buy today, you get a charging cable which is which already adheres with the present market standards, be it CHAdeMO or CCS, so on and so forth. You just have to plug into a 3-pin plug which you install in your home, and you're good to go.
All right. If I may also add to this question, so the question is regarding having slow charging points at home. So if I may answer from my perspective and my experience as well. So I feel that at the time of home construction, you may leave some charging points in your car area, car lobby area, probably having 2 to 2.5 tons of capacity, or maybe 2.5 kilowatt of capacity. So you could have this rudimentary charging setup at your home for any future use. So the next question is that what is the difference between native charging and guest charging in, as you mentioned, in step number 4?
Right. So native charging, actually, we consider native charging is for those vehicles which are part and parcel or which reside within the electric utilities area in itself. And guest charging are those pertains to those vehicles who do not reside in that specific area, but reside outside the residential in that specific area. But they visit the area maybe because of they have their offices there, or because they use an expressway which is passing through that area, or they are going somewhere. So these users, they take a pit stop, they do the charging within that area, and they pass off. So this is so by guest charging, I mean those vehicles who are not residing in that specific area per se.
All right. Next question is by Mr. Nisar Latif from Pakistan. Is there any technical barrier for fast charging with existing slow charging batteries installed in EVs?
Well, technical barriers, if I have to say, yes. I mean, it is a function of demand and supply. So if you see presently in India, the EVs which are coming out, they adhere to the different EV charging standards. They also can be charged through fast charging norms. But in certain cases, they have restricted the charging limits or the charging timings to around 25 kilowatt or 30 kilowatt odd, vis-a-vis another even higher fast charging timings or life cycles of 50 kilowatt and so on, because it would be astronomically high and for a vehicle to actually to be launched in a niche market or nascent market for India, wherein fast charging infrastructure itself has not developed. So even though fast charging technologies has developed, they have curtailed the fast charging that might be done on that car just to reduce the upfront costs.
All right. And the next question is that what is the excise duty on the import of EVs and EV charging equipment in India?
If I remember correctly, the excise duty as of now for EVs is 5%. And for the different EV charging equipment is also somewhere around 5 to 7%, if I'm not wrong, vis-a-vis the other ICE vehicles, which attract an duty of around 18% or so.
So it's 18% for the EV charging equipment, right?
No, it's 18% for the ICE vehicles, I'm saying, the conventional
Okay,
vehicles.
all right. Okay. Next question is that what would be the configuration of solar assisted charging points at homes? Do you have any technical advice or input for that?
Well, on the technical side, I would not be able to add a lot of light to that, throw a lot of light to that. But on an experimental basis, some of the players have already started doing solar powered homes, and also they are charging their vehicles through it. So I don't think there is a very high technical barrier for that technology.
All right. And the last question is regarding the charging station setup, which you have mentioned in step number 6. The question is that the charging stations which you have mentioned, will they have all the 5 standards as you mentioned in step number 6? Each station will have all the 5 standards?
No. So as I said that initially the Ministry of Power had mandated the charging station owners and operators to have those 5 charging points to improve the attraction of charging stations, or to improve the viability or interoperability of different vehicles in that charging stations. But later on that was scrapped out. You have the luxury to actually set up 1 or 2 charging points in a specific charging station, and there is no adherence that has to be put up with respect to the number of points per se, as far as policy and regulatory aspect is concerned as of now.
So for the knowledge of the questioner, could you mention what is the recommended configuration which you have recommended for your utility for the setup of charging stations?
So we have recommended slow chargers at least for the first 5 years. We have recommended slow chargers by and large. Fast chargers can be developed at very key strategic locations. That also, when you are augmenting revenues from any other business source, for example, near restaurants, near commercial hotspots, or in parking lots of malls, or movie theaters, wherein you do not have a single revenue stream from public charging station in itself. So that might be detrimental to actually set up that public charging station in itself. So if you can actually set up public charging stations in strategic locations like these, or in some certain cases you have commercial hotspots near eateries, near key highways. So if you can set up public charging stations or quick charging stations strategically, then I think that can be a business case in those specific locations only. But apart from that, by and large, we believe slow chargers would be the mode to go, at least for the next 5 to 6 years. And we have also recommended the same in the report also.
All right. Last 2 questions. One is by Mr. Muhammad Ali Qureshi. How do you see the market of swapping battery models for EV, especially for 2-wheelers and 3-wheeler rickshaws in India?
For 2-wheelers and 3-wheelers, I feel I am a bit more optimistic for battery swapping in India, because there has been some models that is operational in the country. NCR or Delhi in itself has 2 or 3 operators, battery swapping operators, which are operational. My colleague Peenal also spoke of another battery swapping model which is operational in the city of Nagpur in the state of Maharashtra. So in bits and pieces there are battery swapping models which are operational in the country. But the issue is that in all of these models, you are relying on only one type of vehicle category or one type of vehicle manufacturer. So you have procured vehicles only from one manufacturer, let's say XX, and then you are making an ecosystem out of it. But interoperability between different vehicle categories or vehicle manufacturers is still not present in the country. Different startups or different battery swapping manufacturers, they are trying to make solutions over and above the batteries that are being developed by the manufacturers. So what they're doing is that they're using the batteries that are being supplied by the manufacturers, let's say by manufacturer A or manufacturer B, and then they're developing battery monitoring systems, or BMS as we know. So over and up on top of that, so that is still a work in progress. They're trying to you improve interoperability through that robust BMS systems. So and it still needs to be seen how well and how intrusive it can be beyond certain manufacturers.
All right, and how does the ownership of battery issue is addressed in such battery swapping models?
The ownership does not rest with the owner of the EV itself. So basically, you are buying an EV vehicle, and the ownership of the EV vehicle is on you. The battery swapping system owns and operates the battery. So you take the batteries on lease, if I have to say, and you use that battery. Once the battery is used off, you take it out and you swap it with another charged battery. So your ownership of battery never rests on you per se.
Right. So next question is by Mr. Akhlaq Ahmed. He's asking generally what is the usual time for charging the different segments of vehicles which you have mentioned in your presentation from zero to full charging. He's referring to two-wheelers, three-wheelers, and then four-wheelers. Any estimated rough idea of the charging times?
So if I consider slow charging as a standard to go with, two-wheelers typically take around 4 hours, 3-4 hours at least to top up its entire charging. Four-wheelers again. Four-wheelers might take if I have to talk about three-wheelers, it might take around 7 to 8 hours on slow charging. And for four-wheelers, be it hatchbacks or sedans, then it might take around an entire night, maybe around 10 hours. You have to charge overnight to actually top it up completely.
And by slow charger, do you mean like 5 kilowatt charger?
Yeah,
or
5
is
to
it
10,
like
5 to 10 kilowatt. Yeah.
All right. And the last question of this session is by Mr. Rizwan Majid Khan. His question is how the electricity load shedding and grid connection constraints are handled at EV charging points in India. Do you have battery storage in place at EV charging stations, or is it done without any storage?
See, typically as of today, EV charging stations has been set up in tier 1 cities who do not actually face electricity outages or power outages so often. They might rely on another additional battery backup in the form of generators maybe, but I don't think the technology has not evolved to such an extent that you are using battery storage to or solar powered storage to actually power backup the EV charging station in itself.
True that. So with this, we reach the end of our Q&A session. So thank you very much, Mr. Pramit, for your comprehensive presentation on India. I think we might get a few questions later on because the questions are pouring in slowly and gradually. So I'll note down those questions and will refer those questions to you at the end of the overall session. So dear participants, so now we move on to the next presenter. Our final presenter of this video conference is Mr. Muhammad Haris Akram, who has close to 8 years of professional experience in the power and renewable space. He is presently the program manager at Comstech OIC Secretariat, Islamabad. He has executed engagements on finalization of OIC energy profile, installation of industrial solar PV systems, implementation of energy management system, and devising energy conservation solutions. Mr. Harris holds a master's degree in electrical power energy systems from ComSet's Institute of Information Technology, Islamabad. Mr. Harris will be presenting the action plan developed for ISCO Pakistan. So over to you, Mr. Harris.
Hello everyone, good morning and good afternoon according to your time zones. So I'll be sharing the study of Pakistan. We follow the same methodology as Bhutan and India have delivered. So the methodology for study, we'll be looking into the country EV outlook, then about the shortlisted distribution utilities, public utilities in Pakistan. So then we'll talk about the charging standards, which may be applicable in Pakistan. As of today, that in Pakistan there are no charging standards. And then we'll be looking into the charging requirements in the area of ISCO, Islamabad Electric Supply Company. Then we'll also talk about the planned locations of public charging stations in the licensee area. And then we'll talk about some business models, the Capex requirements, OPEX, and different financial requirements for setting up public charging stations. And then the requirement of organizational capacity for the public utility. So starting off with the penetration of EVs, it started off after the first electric vehicle policy in 2016 in Pakistan, that the hybrid cars were allowed to be imported with subsidies, and it took off very well. But there were no all electric vehicles in Pakistan till 2017, 2018. The first all electric vehicle was imported in 2018. So while we were consolidating the data, we saw that combining the plug-in hybrids and the all electric vehicles, there were around 250 vehicles on roads by the end of 2019. So we've done some conservative estimates according to the policies in place, and the import policies, some manufacturing policies, and some local incentives for these electric or plug-in hybrids. So what we see is that, can you go to the previous slide, please? The last year, 2020, was a bit slow in terms of the traction for EVs, or as far we talk about the IC engine vehicles as well. So what we see is that there is a new policy in place for electric vehicles last year, which was approved by the cabinet, and now it's being implemented in Pakistan. And for that, till date, when we talk about the updates, most updated data, we have two auto manufacturers with EV greenfield license. That means they're going to be manufacturing these EVs in Pakistan. So with policies in place, with the local manufacturing, we see that in the coming years, the traction will for electric vehicles will be more than we've estimated for 2030. Can you go to the next slide, please? So talking about the policies again, in 2016, there was a 5-year automotive policy in which there was a small bit of plug-in hybrids and EV segment. But now last year, there was a dedicated policy for electric vehicles. As I mentioned earlier, that two companies, Zoyte and MG, have got the greenfield license to manufacture EVs in Pakistan as well. And there is another local company with a Chinese partner who have applied for a greenfield license to manufacture two-wheelers, three-wheelers also in Pakistan. So then again, about this EV policy, we'll be having, as few of our friends have asked questions for Bhutan and India as well, that what are the custom duties and taxes on EVs for India and Bhutan. For Pakistan, till date, the EV policy has not been implemented truly in true sense, but the reports have said that it would be around 50% of the custom duty, and the taxes will be waived off, the general sales tax and income tax component. on the vehicle. So next slide, please. So now we'll be moving on to the public utilities. In Pakistan, we have 11 utilities. 10 of them are public and one is private, K Electric. We've seen some matrix to aggregate and analyze these distribution companies, power distribution companies, and we've according to these matrices and parameters, we have come up with that ISCO, Faisalabad Electric Supply Company and Gujranwala Electric Supply Company were the top 3 in terms of all these parameters. And ISCO was the top rated power distribution company in Pakistan. So next slide, please. So while we were closely working with the ISCO regarding this study, that how to implement or to develop the guidelines for implementation of public charging stations in the licensee area. So as few of our questions were also asked regarding the distribution transformers and different things, I would also add to that while we were working with ISCO closely, we saw that we in depth studied that how many feeders are in place and what is the available capacity in these feeders, in dedicated feeders. And then we got down to the distribution transformer level. ISCO has more than 17,000 distribution transformers in the licensee area. And we've sorted that out, that how many transformers still have more than 50% of loading capacity. So according to that, we've tried to manage and locate the locations, and I'll talk in the later slides as well again. So coming to the charger types and standards, for Pakistan, it's a new market for EVs. So all the plug-in hybrids and electric vehicles which are being imported or used or are on the roads, they were being charged through the home chargers. And in 2017, Dewan Mushtaq Motors was supposed to set up 7 charging stations across Pakistan, out of which one was in Islamabad, Karachi, and Lahore. And they were set up in 2017, and they were only specifically for BMW vehicles. But now till date, in Islamabad, we have 2 public charging stations. Unexpectedly, they are owned by the oil marketing companies, state-owned oil marketing company. So, so talking about the standards, globally we have CSS, CHAdeMO, and Type 2 for fast and slow chargers. I have personally visited these public charging stations in Islamabad. They have all the options for CSS, CHAdeMO, and Type 2 as well. That means that any imported car can be charged at that public charging station. So as Pramit said that few of the manufacturers have limited their charging capacity of this electric vehicles. I was going through a report 6 months ago about Tesla, that their wall mount, that means slow or moderate chargers, wall mount chargers have a capacity of up to 45 kilowatts, but their Model S supports only 30 kilowatts of charging. That means if you still have that capacity, but your electric vehicle is not compatible to that charger or that higher level of charging. So we need to see that in our new markets like Pakistan or Bhutan. In India, it's a bit mature market. So we need to have a slow or a moderate charger in the first 5 years, I guess. So, to have more traction, more vehicles on the roads, and more electric vehicle population. So for the charger adoption, we've seen that while looking at the power distribution companies' availability of power and different parameters, we see that the parking lot facilities, home offices may have slow or moderate chargers. For fast chargers, it may be advisable that they can be on highways and markets, malls, and hospitals, etc. But they may be after first 5 years. Next slide, please. So it's again, it's very similar for ISCO, that we have native and guest charging. Islamabad or the ISCO, Islamabad Electric Supply Company, offers power to the twin cities of Islamabad and Rawalpindi. and to some adjacent areas also. So we may have electric vehicles in Islamabad, Rawalpindi city, and in the adjacent areas, or the guests EV charging may be on the highways and motorways, like people traveling from other cities, like from Lahore, from Peshawar, either ways, they'll be stopping over at different stations on the highways on which the ISCO may be supplying power to. So this is how we assessed the EV charging requirements for electric vehicles for native and guest charging. Next slide, please. So we've done some conservative estimates according to the numbers we've got from the Automotive Manufacturers Association, that by 2020 we expected that we'll be having 20,000 plug-in or all-electric vehicles in Pakistan. But due to pandemic, there was a slowdown across the year. So we may not have 20,000 PHEVs or electric vehicles in Pakistan till date. But that's a good news that there are 2 manufacturers who have got license for manufacturing, and we'll be getting good traction in the coming years, and we may cross these anticipated number of electric vehicles on roads. So what we've done is that we have averaged out that across the year we'll be charging for 300 days, and in the initial years, if we have plug-in hybrids and EVs, we may be requiring 10 kilowatt hours of energy for a single vehicle. For 300 days we'll be charging. So what will be the load on the public grid? So it would be for 20,000 vehicles, it would be 68 gigawatt hours. Why this is important for estimating the charging requirements for the public utility? They need to have a proper planning for every fiscal year for future, so that they know what amount of energy may be exactly required, and they may put in their planning as well. Similarly, we've done some estimates for 2025 and for 2030 as well. We've considered the number of days for charging same, and you may see a difference of amount of energy required for a single vehicle. For 2020, it was 10 kilowatt hours because we may be having more plug-in hybrids which have a smaller battery pack. By 2025, the market may get mature as the new entrants and new manufacturers are coming in Pakistan. So we'll be having around 65 kilowatt hours of battery packs in the cars on an average. And by 2030, the EV market may be so mature that we'll be having on an average 90 kilowatt hours of battery packs in a single electric vehicle. So as of today, the public utilities don't have a proper planning for EV load management. So when we were working with them closely, so they have planned for the next year, for 2025, medium term and long term for 2030, that they'll be including these amount of charging required for the public utilities. Next slide, please. So talking about the location planning of EV charging station, as I mentioned earlier, that we closely worked with the power utility, and we've done detailed analysis on the available feeders, the loading capacity of feeders, the loading capacity of distribution transformers, and more detailed analysis regarding the economic profile of that area, the connectivity, or the available public spaces. Even if there is a mall, and we see that in Islamabad there are some issues of parking spaces as well. So we've considered all these aspects of while planning the public charging stations in the licensee area. So next slide, please. So these are some stats, and we've also put in some names as well, which may be designated for future public charging stations. Like for example, if we consider that for some public parkings, there may be airports and some civic centers, a public park, or government offices, and some shopping malls, hospitals, universities, which may get initial traction for electric vehicles as well. So we have done some energy requirements, that what type of chargers and what is the capacity of chargers that may be used in initial years. Similarly for malls and hospitals as well. So we've divided into this into two phases. Initially, we used the slow chargers of up to 15 kilowatts, and for the next year, we move on to fast chargers as well. Next slide, please. This the public charging station density may be increased according to the requirements as well. So coming on to the Capex requirements, that how much amount may be required from a private investor or a public utility or a PPP mode model for setting up these charging stations. When we were drafting this report for Pakistan, these were the estimated costs, import cost of these technology of chargers, CSS, TDM, and Type 2 chargers. At that time, there were some custom duties and taxes applicable to these type of charges imports. But now, as the EV policy is in place, there are some subsidies on the import as well as local manufacturing as well. So these costs may be revised in future or while setting up these public charging stations. So the initial cost or the major component of the cost would be the charger itself. Then other costs may include the electricity connection, the civil works or the lease agreement of the area. And at last, it would be the management software for that public charging station. Next slide, please. So this is the breakdown of the Capex requirement, that you may see that the major component would be for the charger itself, then the transformer cabling. Transformer and cabling is actually an auxiliary component. At some sites, it may be required, and at some sites, it may not be required. So it would be a case-to-case scenario. We've also, when we saw the first charger, public charger in Islamabad, we saw that it was by an oil marketing company. So they do have a dedicated feeder. They do have a distribution transformer which has the capacity to bear the load of semi-fast EV charger. So they may not be, while setting up this charging station, they may not have incurred the cost of transformer and extra cabling. So their major cost would be the charger itself and its software. So we break down this into the equipment cost and some services. That's like the staff maintenance and technicians and etc. Next slide, please. So this is analysis for a business model that we've done analysis for the earnings of 1 rupee to 4 rupees per kilowatt hour from different types of charging stations. If we set up a slow charging station, and we have calculated that what would be the rate of return on the investment for different revenue streams from 1 rupees per kilowatt hour to 4 rupees per kilowatt hour. We've done this analysis only for a 15 kilowatt slow charger and a semi-fast for a 25 kilowatt charger, because we feel that in the initial years, these may be only financially viable models. Next slide, please. I would also add from the previous slide that the detailed numbers are also given in the final report as well. So you may consult these numbers as well for detailed analysis. Then talking about the business models which may be suitable for the new market of Pakistan. Initially, what we thought was that the public utility may be setting up all these electric charging stations, but as being the public utility, so they have their own restrictions and limitations. So what they've offered was that what they can do is that for a specific site, they may provide the distribution transformers or cabling or the services for providing power provision for that specific area. So we've come up with some public-private partnership model that it may be of 15 years between the public utility and a private investor who would be bringing in some who will be putting in money for the charger itself, and the public utility may be investing in public the distribution transformer and cabling or any power services required for that area. And for the BOT model, it may not be suitable for the initial initial years as that for a private investor, it may not be because the EV, as the EV EV penetration is very less in the initial years. So he may not be getting the revenue or the rate of returns that have been estimated earlier in the earlier slide. Next slide, please. So then what needs to be done to make it financially feasible for the Pakistani market? It may be initially, it may be in terms of grants and subsidies by the government to reduce the capex towards the station deployment. As I mentioned earlier, that there has been some subsidies for the import and local manufacturing of chargers itself. So that's the step forward for having more EV penetration for the upcoming years. And then another thing, that's the electricity tariff or a special EV tariff for the public charging stations that also have been addressed in the initial presenters slides as well, or some questions, I guess. So that we do not have a specialized EV tariff, and it was being answered by my friend from Bhutan that the public utility also has to pay for the power purchase. So then they'll have add as a service or a value addition, and then they'll be selling to the consumer. So a public utility, or like in Pakistan, there is Power Regulatory Authority. They may have a policy or a special tariff for EV charging infrastructure as well that may be subsidized for the initial years. For city governments and municipalities or highway authorities, they may also mandate some spaces, dedicated spaces for setting up these EV charging stations, public charging stations. Then the public sector or the large private companies or the shopping malls, large shopping malls, as Pramit said, that they have other business streams as well. They may also start off with setting up these public charging stations. Next slide, please. So this is some analysis that for the first 5 years from 2020 to 2024, we'll be seeing less EV penetration. That is because it's a new market. Then for public charging station itself, as we don't have more EVs on roads, we may also not have more requirement for public charging stations. And initially people would be preferring to have these cars charged from their home chargers. And what would be the recommended model for the initial 5 years would be the PPP mode, as I discussed earlier, that it would be between a private party and a public utility as well. And what type of public charging stations would be preferred for the first 5 years? It would be slow and semi-fast. And as we do, as the fast chargers may not be financially viable in the initial years. And for having successful installations, the government subsidies should be in place according to the EV policy. For the next 5 years, from 2025 to year 2030, we'll be seeing a medium penetration, and we expect that the anticipated number of vehicles may be increased in coming years because of the support policies and local manufacturers coming in. And the recommended mode of public charging station would be still PPP, and it may be then owner operator mode. As I mentioned earlier, that we've seen that in Islamabad, the first public charging station, publicly available charging station, was set up by Diwan Farooq Motors, BMW owners, and then it was by oil marketing company, state-owned oil marketing company. Next slide, please. Most importantly, at the end, we'll talk about the organizational capacity. As in my initial remarks, as I mentioned that in Pakistan, we have 10 public utilities. Sorry to say that the bureaucratic procedures in the public utilities is not at par with as the private sector governs all these modes. So what we recommend is that we've closely worked with the public utility of Islamabad, that they may be having a separate cell for electric vehicles for its operations, licensing, marketing, and for its management softwares as well, so that they may be communicating with each other, all the public charging stations, for vacant spaces, available spaces, and regarding the operations, the public utilities already have these have separate staff for such cells. For licensing, a proper program should be developed with the government's approval or the Power Regulatory Authority approval, that what is the licensing procedure, what are the minimum requirements for setting up these public charging stations. And for marketing, it's important because it's a revenue stream. You need to market this for the new market. And so for this, public utility may be requiring this dedicated marketing department for publicizing this public charging stations owned by public utilities. And at the end, the IT department, it would be capable of managing all the software updates for EV charging stations or communication between the charging stations and the utility, etc. Next slide, please. And then again, because for Pakistan or any public utility in Pakistan, it's a new field. So necessary skills and management skills would be required to implement this program and smooth full operations of this program. So maybe capacity building, trainings of professionals may be required for this department as well. Next slide, please. So I would conclude that in our analysis, we expect that by 2030, Pakistan will be having 15% of new electric vehicles on roads. It may be four-wheelers, three-wheelers, and two-wheelers as well. It's estimated at 1,000 people per electric vehicle, or 1 million electric vehicles on roads by 2030. So government's push policy incentives is required to increase the uptake of EVs in Pakistan. Based on practical and feasibility, it is suggested that public utility invest in make-ready public charging station installations by setting up necessary distribution networks, transformers, meters, and other electrical equipment in place. Delivering power to ready-to-build sites is more practical approach to give a push start for setting up charging infrastructure in the licensee area. This will shield the public utility from unwanted risks and uncertainties in the EV space. Our economies are expected to be more conducive and EV sales grow and the market matures, thereby bringing down charger costs and improving station utilization. I would again add to this that when things are locally indigenized, the costs definitely come down. Next slide, please. So I will thank you all for listening patiently to my talk. If you have any questions, you are more than welcome.
Thank you very much, Mr. Harris, for your presentation. We do have some questions. So the first question is that how much would be the requirement of the trained HR for the first phase in Pakistan, which you have mentioned in your slide?
Sorry, can you repeat the question?
Yeah, the question is that how much would be the requirement of the trained HR, trained human resource, for the first phase, which you have mentioned in Pakistan? The first phase is from 2020 till 2025.
As we've discussed with the public utility, they were of the view that they may designate few of the resources from their existing departments, and they'll be training over the years in the different fields and different departments and setting up separate EV cell. So it may not be quantified that how many people may be designated, but it would be according to the EV penetration increase in the public utility area.
All right. Another question is from Mr. Akhlaq Ahmed. He is asking that, do you know about any initiatives taken by distribution companies such as Lesco or K Electric with regards to EV promotion?
Till date, no. The reason is that as it's taking off, the policy is taking off and its implementation is starting in Pakistan. So unfortunately, while developing these the EV policy, the government did not take the public utilities on board or the Power Regulatory Authority on board while developing these policies. So they were while we contacted them and we've discussed all these aspects, And now there is a separate electric vehicle development board as well in place, which will be which will be having stakeholders from public utilities, from academia, from industry, from auto manufacturers. So all the stakeholders will be on board, and in future, hopefully, these public utilities will have initiatives publicly and on their websites as well.
Thank you. The next question is about the status of the EV policy. So what is the current status of the EV policy? Is it advertised in the Gazette of Pakistan? There doesn't seem to be any update on that side.
It's not still updated on the Gazette. It's still in the implementation phase. It's been finalized in the last month, and it's approved by the cabinet. As I mentioned earlier, that in the initial policy which was approved by the cabinet, it was very vague. But in the last month, more details have been out publicly. FBR have been notified already for the tax exemptions and import duties as well. But I will have to check from the Gazette that is it publicly available on the Gazette or not. But I'm sure about that. The FBR have been notified by the government that what is the excise duty and taxes.
All right. Another question is from Mr. Muhammad Ali Qureshi. His comment is, as far as the localization of EV charging infrastructure is concerned, what role do you see for academia in developing the integrated value chain for charging infrastructure?
As I mentioned in my previous answer, that there is a electric vehicle development board being organized by the EV manufacturers and importers. They have stakeholders from academia, from industry. So what we see is that there are some research groups which are working in academia and are also on board with engineering development board as well as auto manufacturers association as well. So we see a very strong connection between academia, industry and manufacturers in future.
All right. Another question is, how can Capex requirements for a slow to moderate charging station be reduced? As you mentioned in your presentation that the Capex requirements are high.
They may be reduced by local indigenized technologies, because we start importing things, the things will not come down due to the exchange rates and other tax duties and policies. So being indigenized technologies, we may see some reduced Capex costs.
All right. Last question is by Mr. Clark. Installing EV charging at home might not be possible with 10 kilowatt requirement. So it's a comment and he's asking your opinion on this.
For a 10 kilowatt charger, yes, it may be true, but our power sockets for air conditioning and other power requirements for like microwave ovens, we do have a 2.5 to 3 kilowatts of charging capacity. And while constructing new homes, we may have a dedicated, if we have a 3-phase meter, we may have a connection or a commercial connection available for 10 kilowatts as well.
All right. With this, we reach the end of the Q&A session. So we haven't received any further questions for our previous speakers yet. So I would like to conclude the question and answer session and move towards the conclusion session. Have we got one more question? Yeah, so we have one more question. Wait. Let me check. Yeah, so this question is from Mr. Nisar Latif. He's asking, how do you see the option of manufacturing EV charging locally in Pakistan? Are there any provisions in the current EV policy? And what is your opinion on the local charging? Because for now, what I have myself seen is that there have been import relaxations for the import of charging stations. But is there any further input in the policy for the manufacturing of charging stations locally?
Yes, there is. There is a part in local indigenization. If you import some components of a EV charger, like the capacitors and different electric components, there is also a subsidy on them as well. And there are some companies. One I know of is in Lahore, Microtech Industries. They are already in the development phase of these EV chargers.
The current charging stations which have been which we see are being installed in Islamabad, Lahore, and elsewhere, I guess they are imported from ABB International, right?
Yes, they are ABB.
Okay.
According to the import documents, 31 have been imported, but we don't see 31 installations in place. We only see 2 or 3 installations in place till date. But according to the import documents of 2020 December, 31 charging stations were imported.
So were those 31 charging stations imported in December only, or like is it an aggregate number?
It's an aggregate number, and it was imported by the oil distribution company.
All right. We have I just received 2 more questions. One is from Mr. Rizwan Majid Khan. His question is for the fast charging stations where a cluster of chargers are needed to charge multiple electric vehicles at the same time, like on motorways. So don't you think there is a need for battery storage to ensure uninterrupted charging and grid capacity management?
As Pramit answered this question in his comments as well, that this market is not so mature yet, that we may have to invest separately for the battery storage as a backup or a diesel genset as a backup. So in the initial years, these are in tier 1 cities or highways, like, and they do have their backups as well, or uninterrupted power supply in these areas.
All right. Final question is from Mr. Akhlaq. He's asking, I need to know if there is a 2.5 kilowatt charger available that we may install at home. If I may take the liberty of answering it myself. So as our presenters mentioned it previously as well, that each car comes with its own charging, with its own charger. So each manufacturer has a different charger. So there are different charging standards being followed, and Mr. Pramit Paul in his presentation, he mentioned a few of those charging standards. For slow chargers, there's already a charger being provided with the car. So if you buy an electric vehicle, so that slow charger will be for 2.5 or 3 or 5 kilowatt charger will be provided. But if you want to buy it separately, then the manufacturers of those electric vehicles, along with other spare parts, so they do provide the chargers as well. So one more question. Sorry. Question is from Mr. Rafiullah. What are the impacts on job market with increase in electric vehicles in Pakistan? Is there any study which can quantify these? So yeah, impacts of EVs on employment. So not just specific to Pakistan, if any such study has been done in India as well, so you might want to answer this. I think Mr. Penal wants to answer this question.
Very specifically, of course, it has an impact on overall job market. Definitely, it's an emerging technology. However, it again depends upon the entire ecosystem within each country. What is going to be the penetration? And yes, of course, all the countries are now focusing, including India. We are focusing on having locally manufactured components, auto components, locally manufactured EVs. Definitely, this is going to drive the investment in the country, and therefore in turn it will drive the job market definitely. However, these are all specialized and emerging jobs where specifically a very specific expertise is required, and definitely it will have some impact on the job market as well. Yes.
And just to add to what my colleague said, in India, what we are seeing now is that different public sector entities has been given mandates to increase their expertise in the new clean energy segments. For example, the India's largest coal-fired thermal power plant owner, like NTPC, they are also entering into EV segments. India's public sector entity who is into manufacturing of electronic parts, called BEL or BHEL, as we know, they are also intending to enter these spaces. So they have specific mandates from the government. One is to look towards new energy targets to clean up their balance sheets, or to clean up their energy sources. That is one thing. And also this is being a prosperous economic activity in the years to come, so everyone is very eager to enter into this space.
Very well explained. Thank you. So with this we reach the end of our question answer session. I would move towards the conclusion and recommendation session, where I would summarize the conclusions and recommendations of this report, and which were already presented in this report, in this presentation as well. So we basically started our session, and our report also started with the overall EV global context. The major conclusions were that the EV market has been growing quite steadily across the world, driven by developed economies and majorly by China. So the growth in China is one of the major drivers in the EV market growth. With maturing battery technologies and reduction in prices, the cost of EVs is expected to decrease further going forward, and this will be another big driver in the overall growth of EV market. With regards to battery swapping system, it was mentioned by the presenters as well that it is an evolving concept, and because majority of OEMs, they prefer to guard and to keep their designs separate, and they want to have control over their EVs and their designs, as well as the design strategies of the battery packs. So because of this, there is a lack of standardization across the manufacturers. Therefore, the battery swapping system, it might suffer because of that lack of standardization. Moving on, our second presenter, Mr. Shivang Lenduk, he explained the action plan for Bhutan Power Corporation. He explained that the government, it continues to give support in the form of financial subsidy or tax rebates to make electric vehicles more affordable for its citizens. And there is basically free electric vehicle charging available in Bhutan in the 4 locations where the charging stations are already installed. According to the study which was carried out by 2030, it is expected that under the low uptake scenario, there would be around 950 electric vehicles in Bhutan, particularly under the BPC licensee area, and under the high uptake scenario, there would be around 2100 electric vehicles. So taking the low uptake and high uptake scenario further on, the financial projections and the overall costing was done. The location planning of electric vehicle charging stations was also carried out in the report, and total number of electric vehicle charging stations that were to be installed by 2030, the exact locations were identified in our report. Afterwards, the Capex requirement for the charging stations was calculated, and it was in the report, it was described that around 2.75 million per million Gultram, which is equivalent to Indian rupee. So around 2.75 million Indian rupee per charging station would be the Capex requirement with regards to Bhutan Power Corporation. Under the low uptake scenario, which it means that for all the charging stations, the overall Capex requirement would be 100 million. And under the high uptake scenario, the overall Capex requirement would be 190 million Nigultran. Similarly, the OPEX requirement was also calculated, and then the financial viability of charging stations was calculated using the business models, 4 business models which were developed in this report. Overall, it was calculated that the model number 3, the option number 3, under which the initial investment is to be done by the government, and then the operation and maintenance of the charging stations is to be taken care of by private sector or by the utility company. And under this option business model, the electricity selling price recommended in our report is 8 Nugultram per kilowatt hour, and the electric vehicle charging station utilization rate assumed on the basis of which these calculations are done. So the assumption is that the utilization rate of the charging station would be around 25%, and this is found to be most sustainable option with regards to the utility. Because in this option number 3, the government does not have any risk at all, and it will be able to recover the initial investment of the charging stations at the end of the lease period. So moving on, next, Mr. Pramit Paul, he gave the action plan for the Indian utility BSES Yamuna Private Limited. So with regards to the Indian utility, the same procedure was carried out, the same kind of analysis was done, and it was estimated that the overall charging requirement in the utilities area by financial year 2024, it was calculated at 258 megawatt hours of charging requirement would be needed, and by 2030 it was estimated that 720 megawatt hours of charging requirement would be needed per annum. So as you can see that the Indian utility is quite far ahead when it comes to the maturing technology or the maturity of EVs, as you can judge by the number of kilowatt hours which have been forecasted and predicted. Afterwards, the same procedure was followed, and location planning of EV charging stations was done in the private utilities licensee area. And it was found out in the analysis that 6 divisions out of the total 14 divisions for the BSES Yamuna Private Limited, so 6 divisions were found to be suitable for installation of charging stations. And even in those 6 divisions, major areas for prospective charging station installation were mapped out in the report, and it's available in the report. The Capex requirement for the charging station was estimated to be around 20 to 24 lakh Indian rupees, with each charging station having 5 standards. But it was estimated that in the current market scenario where the EV sales have not been picked up, so for the promotion of 4-wheelers, EV charging stations with all the 5 charger modes, it seems unviable. So this 20 to 24 lakh rupees per charging station Capex requirement, it might come down more based on if you go with 1 or 2 particular charging standards. So overall, fast chargers were predicted to be not viable even with subsidies. So therefore, for the Indian action plan, Indian utility action plan, so slow to moderate chargers have been recommended. When it comes to the business model development, the recommended business model for the initial phase, initial 5 years of the utility, the public-private partnership mode has been recommended. And for 2025 till 2030, the next phase, so PPP mode with owner-operator mode in strategic locations has been recommended in our report. Basically through for the next 2025 to 2030, because the battery technology will mature, and it will the cost of the batteries will come down, and the cost of EVs will come down. Therefore, the owner-operator route is recommended to be explored in strategic locations, while keeping the public-private partnership mode as the mainstay. Now coming to Pakistan, again the same methodology and process was followed. The location planning of EV charging stations was done again in 2 phases. In phase 1, certain locations were identified, and then for phase 2, from 2026 to 2030, more locations were identified. Again, just as for India, fast chargers were found not to be viable, same in the case of Pakistan. The slow chargers up to 15 kilowatt in capacity have been recommended. The capex requirement for installation of the charging station is 6.7 to 7 million for each charging station. So this is quite high in terms of Pakistan, 7 million per charging station. So with this capex requirement, it was estimated that overall 92 million rupees, Pakistani rupees investment has to be done by the public utility towards PCS in the charging station installations in its area. Then the business model development for the charging stations was carried out for Pakistan, and it was basically assumed that based on practicality and feasibility, the suggestion is that the public utility should invest in make-ready charging station installations by setting up necessary distribution networks and transformers, meters, and other electrical equipment. So the electric utility should be basically setting up the infrastructure for the charging station, and the charger cost and other supply equipment will be set up by the interested private parties, and the operation and maintenance of these sites will be the responsibility of the host of the EV chargers, and the maintenance could be sublet to service companies, or these maintenance charges could be incorporated under the tariff models. So delivering power to a make-ready site is more practical approach for ISCO, the charging, the utility for in Pakistan for which this analysis was done. Finally, with this overall conclusion of this report and this presentation, I would like to seek further inputs from our participants as well. Basically, the overall purpose of organizing this video conference was to gain feedback on the report which has been done, the action plans which have been made and suggested for the 3 utilities. So the input and feedback from the stakeholders and from general public is quite important for improving our report. So with this purpose and with this background of this video conference, I would like to invite you to submit your feedback and your comments to SAARC Energy Center. You may send all your comments and feedback to either info@saarcenergy.org, or you can address it directly to me, rfete@saarcenergy.org. So your comments would be beneficial because we would later on improve our report before publishing the final draft of the report. So with this, I would like to conclude our video conference. Thank you everyone for attending today's session of the video conference, and we listened to very excellent presentations delivered by our author team. All the presentations are already available under the handout tab of this software, but later on these presentations will be made available on the SAARC Energy Center website as well. I would like to reiterate that we would love to hear feedback and your suggestions for any further improvements. So we are open for that, and if you want to suggest any future topics on which you want us to organize video conferences, so we are also open for that, and we would gladly do that as well. So with this, I would like to sign out. I would like to thank you again for joining us today, and I look forward to seeing you next time in our next series of webinars. So thank you once again, and goodbye everyone.